Hi, so we have so far discussed Newton's first law and second law, and they were pretty similar. And Newton's second law, particularly, was a mathematical version of Newton's first law. But Newton's third law is a bit different. It actually states some principle that forces follow, and this is like a constitution for forces, and this is like a law for forces that they follow. And pretty, it is pretty interesting. Let's actually see what Newton's third law says. So Newton's third law actually states that action and reaction are always equal and opposite, right? So action and reaction are always equal and opposite, and there are other versions of Newton's third law that go by with different words, like action and reaction are always equal in magnitude and opposite in direction. And you could actually come up with your own wording, but Newton actually stated it pretty simply with very short, choice of words that says action and reaction are always equal and opposite. So there are a few terms that we need to take a look at. So first thing is action. The second thing is reaction. What is equal and what is opposite? So we need to just discuss these four terms in order to understand Newton's third law. It is pretty simple. So action is that whenever you exert some force to something, exert a force on something, right? So that is called as an action, right? So for example, you have a table, right? So let's actually keep it practical. We are going to discuss a daily life example. We have a table, right? And we are going to exert some force on that table, which should be regarded as action. So what would action be in this case? For example, you just put a glass on the table, right? So you put a glass on the table. It is having some weight, right? So weight is acting downwards. That is basically exerting a force on the surface of the table. So that is action. So this W thing, the weight of this force is basically an action on the table because it is exerting a force on the table. So exerting a force is an action. And let's discuss what is a reaction. A reaction would be an equal and opposite force that is provided by the table, but in the opposite direction, right? So yeah, so in this case, we have discussed what is a normal force. In this case, the normal contact force by the table will actually provide an equal reaction to the action that we provided to the table, right? So the normal contact force would actually be the reaction in this case. So you are actually exerting some force on the table, and the table in return exerts the equal amount of force on the glass. That is why both of these forces are equal, and you could say that the glass is in equilibrium. That's why it is statically staying on the table and not really doing any sort of motion. So you can see that the force that you just provided actually received a reaction, and the reason or the fact that the glass is in equilibrium is a proof that action and reaction are actually equal, and hence they are opposite, because they're opposite, they cancel the effect of each other and they're staying static. Or you could just actually come up with other examples, like for example, you can think of yourself in a boat, and for example, you are in a boat, right? So you're in a boat and you just push the water backwards with paddles, right? You push the water backwards, and in return, you as you exert the force on the water in backward directions, the water is going to exert an equal and opposite force to you in the forward direction, and hence you start moving forward. So you're applying force backwards, and in return you're getting a reaction that is causing you to move forward. You can also observe the similar phenomena happen to you whenever you shoot a bullet with a gun, and you just see a reaction to you that actually pushes you backwards, right? So there could be a lot of examples, and you could actually be coming up with more and more examples from your daily life. But this is pretty simple concept that works with forces, and forces obey this law. And Newton actually discovered it perfectly, and he stated in very perfect terms: action and reaction are always equal and opposite. And you must conclude that whenever there's an action, there has to be a reaction, which has to be equal and opposite in direction. That is precisely what Newton said in his third law.